We've got one loop in the top half of the circuit and a second loop in the bottom half, and there's actually a third loop here too. It's the entire outside of the circuit loop. You have one 20-volt battery and two resistors, a 5 ohm and a 40 ohm one. You know that there's a voltage gain across the battery and a voltage drop across both resistor 2 and resistor. To Ohm's law, you can substitute the voltage drop across each resistor with the current times the resistance. Now you've got two unknowns in this equation, which we'll call equation 2. Let's set that aside as well. Next, let's look at loop 2. In this loop, you've got two batteries and three resistors. If you follow the direction of the loop, you see that both batteries add voltage because the loop direction goes from their negative end through to the positive. Now you want to do the same thing you did for the first loop, which is to sum up all the changes in voltage to 0. And then you just substitute Ohm's law in for every resistor's voltage to get terms of current and resistance. Now you have this third equation, which we'll call it. So at this point, you have the three equations you need to solve everything. So let's first revisit equation 1 and replace I1 and I3 with equations 2 and 3. Now you have an equation entirely in terms of I2, which you can solve to find that I2 is equal to 1 ampere. Once you have this value, you can easily solve equations 2 and 3 by substituting in the new I2 solution. For instance, the voltage drop across resistor 2 would be the resistance, 5 ohms, multiplied by the current passing through that resistor, which is 1 ampere. And the drop across resistor 1 in the same loop would be the resistance, 40 ohms, times the current through the resistor, which is 0.375 amperes. That comes out to a voltage drop of 15 volts, which makes sense because then the sum of each drop in the loop is equal to the voltage